Welcome to today's Explainer. Right now, we're stepping into what is basically a cosmic crime scene. It's this fascinating astronomical mystery that completely puzzled the greatest minds for generations. We're going to look at one single, seemingly minor anomaly in our solar system that literally broke the laws of physics as we knew them and forced us to totally rebuild our understanding of the universe from the ground up.
So when you picture a planet orbiting a star, you probably imagine a simple, perfectly repeating loop, right? Kind of like a runner on a track, just hitting lap after lap in the exact same footprints. But that's absolutely not what's happening with our innermost planet. Mercury moves around the sun in an elliptical orbit, an oval shape, but the ellipse itself slowly turns over time. It's not a repeating loop at all. It's a constantly shifting journey. Every single time Mercury completes a lap, its path is fundamentally misaligned with the lap before it.
Section 1. Mercury's shifting orbit, defining the cosmic anomaly.
Okay, so in astronomy, this weird behavior has a very specific name: Perihelion Precession. Let's break that jargon down a bit. Perihelion just means a planet's absolute closest point to the sun during its orbit. And precession, that refers to the gradual shift of that point. So with every single orbit, Mercury's closest approach to the sun just inches forward a little bit. This means the entire orbital path is rotating over time. It essentially traces out a pattern that looks a lot like a giant cosmic spirograph, instead of just perfectly repeating itself. That shifting perihelion right there, that's the heart of our mystery.
Section 2. Newton's unsolved mystery, the flaw in the law.
And the flaw really comes down to this exact number, 43. Specifically, 43 arcseconds per century. Now, to put that into perspective, an arcsecond is a spectacularly tiny measurement of an angle. We're talking about a shift so small there is literally no way you'd ever notice it with the naked eye. Isaac Newton's laws of gravity were incredible. They could perfectly predict almost all of Mercury's motion, but they were off by this one tiny amount, exactly 43 arcseconds every 100 years. Now that sounds totally insignificant, right? Actually, scratch that. In the absolute precision of celestial mechanics, this minuscule, unexplained shift was a massive, glaring problem for classical physics. It completely broke the rules. It meant our fundamental rulebook for the entire universe was missing some pages.
Which leaves us staring at the ultimate question here. Why does it happen? If classical gravity couldn't explain this strange twisting orbit, what possibly could? This tiny gap in our knowledge really set the stage for a revolutionary answer that was about to change, well, absolutely everything.
Section 3. Einstein's revolutionary solution, the reveal.
Enter Albert Einstein. He realized that the sun's massive weight doesn't just pull on planets like some invisible tether. Instead, it actually curves the very fabric of space-time itself, warping it incredibly strongly right up close to where Mercury lives. So Mercury isn't being pulled, it's just trying to follow a straight path through this heavily curved environment created by the sun. And as a result, its orbital path slowly rotates. The precession is just a natural byproduct of the curved space it's constantly traveling through. And Mercury was the absolute perfect test subject for this. Because it's the closest planet to the sun, those relativistic effects, that intense curving of spacetime we were just talking about, are at their absolute strongest right there. When Einstein finally ran the complex mathematics of his new theory of general relativity, his prediction for how much the orbit should shift matched the missing 43 arcseconds perfectly. I mean, it hit the nail on the head. This wasn't just some neat mathematical trick. It represented one of the very first major successes of general relativity, confirming his wild ideas with actual, observable data.
Section 4. Redefining gravity itself, the paradigm shift.
So what does this all mean for us? Well, this solved mystery is a massive paradigm shift, a real game changer. The old view, the one we'd relied on since Newton, was that gravity is just this pulling force acting at a distance, a magical tether between objects. But the new view, proven by Mercury's shifting orbit, completely redefines our basic understanding of reality. Gravity isn't just a force, gravity actually comes from the curvature of space-time itself. Matter tells space how to curve, and space tells matter how to move. By solving that tiny 43 arcsecond mystery, we suddenly realized we were living in a much more dynamic, bendable universe than we ever could have imagined.
Ultimately, the whole shebang boils down to this wonderfully simple sentence. Mercury's orbit shifts slightly because the sun curves space-time around it. It's perfectly packaged, but it contains a literal universe of complexity. Understanding this lets us see our solar system not just as rocks spinning around in an empty void, but as objects rolling across the warped fabric of the cosmos. Which leaves us with this final thought. If the massive sun can bend the very geometry of space enough to twist an entire planet's orbit, well, what other incredible, mind-bending mysteries might curved spacetime be hiding out there in the dark? Keep wondering, keep looking up, and thanks so much for joining me for this explainer.